Hey team, in this video we're going over areas of rectangle, parallelogram, triangle, rhombus, kite, and trapezoid. Alright, let's get to it. We have the area of a rectangle, we're going to start there. And so this formula, pretty basic, you know and love it to be, area equals base times the height. Or you could say length times width. I'll go with the base and height. So here's our rectangle, it's formed by 4 90-degree angles, and we have the base here, and the height would be here. And so if you were to say the base is 5 units and the height is 3 units, the reason this works out is because we'd have 5 equal spaces for our base, and you'd have 3 equal spaces for your height, giving you a total of 15 units squared. So base times height, 5 times 3 would be 15 units squared. The reason you'd have to square this is because it's 2 dimensions. You have a base and a height, or a length and a width. Okay, next up, let's look at the parallelogram. And so this one is going to be very similar. We would end up having the same formula as the rectangle. And so I drew it in 2 different shapes because if right here we'd have a parallelogram, and so this would be the base, this would be the height. However, if I were to move this triangle piece over to the right side, assuming my drawing was fully accurate, you'd end up with a rectangle again, leaving you with the same formula as before, base times height. And so this would just be a challenge if they kind of hid the base from you or hid the height from you. They give you the diagonal length, and it still crosses that 90 degrees with the base and the height, and so you might have to use Pythagorean theorem on some of the problems if you were to give yourself an extra challenge on parallelograms. Alright, next up, triangle. How is that formula derived? Well, it's going to be very similar. Let's go ahead and look at a triangle through the lens of a rectangle. Here we have our lovely rectangle. And if we were to cut it in half, let's redo that line. So if we were to cut this in half, we'd have 2 triangles. And so hence the formula will be base times height divided by a 2. Alright, let's look at the next formula. We have rhombus and kite. I will show you the formula for a kite. So let's do our best to draw that shape. Okay, not too bad, and let's draw the diagonals in there. So I'm going to label the longer diagonal D1 for diagonal 1, and the other diagonal D2 for the second diagonal. And if you notice here, we have a triangle on the left side, and we also have a triangle here on the right. And so if I know anything about triangles, it'd be this base times this height divided by 2 would give you your area. Well, if I were to take this whole diagonal, right, this one from here and going to the left, it's half of that second diagonal, half of that D2. And here would be on the right, the second half. So if I were to take that whole diagonal times this whole diagonal divided by 2, that would be my area. And that works for a kite, and it works for your rhombus. And so the formula for both of them would be diagonal 1 times diagonal 2 divided by 2. And the last one, trapezoid. Let's take a look at that formula. And so here would be our shape. It's the only quadrilateral with only one pair of parallel lines in the quadrilateral family. And then we have the height here, and we have 2 different bases. Here we would have the first base, here we'd have the second base. And the area works out, we would want the base, we want to use the height, but we have to take the average of these bases. So we'd have the area equals the height times base 1 plus base 2 divided by 2. And that would be the area of the trapezoid. And before we get to the example, one more way to look at this trapezoid. And I said we wanted the average of the bases and then the height. So let's check it out. If I were to take part of that trapezoid, let me try my best to draw the bottom half. And so taking these 2 pieces would make that trapezoid up above just a little off. If I took the top half, flipped it upside down, and moved it to the right, it would form, looks like, a rectangle. And that's why it would work to be base times height. And say this line over here was slanted as well, well then it would form a parallelogram, and the parallelograms also have that same exact formula. Okay, now let's move to the examples. The first one will be a parallelogram. So here is our parallelogram, and this time looks like we need to work backwards using our area formula to find the missing height. And so we want to find the height here. Looks like we have a base times a height. We have a base of 14 and a height of 8 in our original parallelogram. But if we were to flip this on its side, they're asking us, hey, what would the height be here? If your base was 10, what would the height be? And that we don't know. So let's start with what we do know. We know the original parallelogram is 8 for the height and 14 for the base. So if we have a lovely formula base times height, well, that would just be 14 times 8. And that would give you an answer of 112. And we don't have any unit of measurement, so we'll just say units squared. And we're not done yet because our goal here was to find h, the other height. And so we have to work backwards. So right now we know the area of this parallelogram is 112. And we know the base would be 10 if we flipped it on its side, and we don't know the height. And so, to solve for h, well, we use the formula area equals base times height and work backwards. So it looks like we have to divide by 10. And so h would equal 11.2 units. Okay, let's take a look at the next one. So this one, we're going to look at a triangle. So here we have a triangle, and it looks like our base would be 5, and the height would be 1.9 centimeters. So here's our formula for the triangle. We had what base times height divided by 2. That is our triangle. And so, plugging it in, our base was 5, and the height is 1.9, and we divide that by 2. So let's see, this almost cancels. It's almost 2 over 2. It's almost 5, so probably just under that. And so 1.9 times a 5 is 9.5. Divide that by 2. You're going to get 4 3/4. Or you could say decimal form, 4.75. And we do have a unit this time, so it'd be centimeters squared. Okay, so that's an example of our triangle. Moving on to the next, let's take a look at the rhombus. I'll actually show you a kite. So here we have a kite. And it looks like the diagonals, we have diagonal 1 would be 3 centimeters plus this 1 centimeter here. Diagonal 2 would be this 2 centimeters plus the 2 centimeters over here on the right. And so we have to add those together because the area for a rhombus or the area of a kite would be diagonal 1 times diagonal 2 divided by 2. So diagonal 1, we said, what, 3 plus 1? That's going to be 4. And then diagonal 2, oh, hey, what do you know? That is also 4. And divide this by 2. Okay, 16 over 2 will give you 8 centimeters squared. Alright, let's move on to the last example. Here is a trapezoid. So the area of a trapezoid we had above, it was area equals the height times base 1 plus base 2. So we want the average, and then we divide that in half. And that was the area of a trapezoid. Well, looks here, we don't know the height. We do know base 1, we know base 2. We don't know the height, we have to figure that out. And so we have this dotted line here. It looks like a 60-degree angle there. And this would make a right angle if we were to draw that in. So we're given a right angle. We have a triangle here. We have the bases. We need to figure out the height before we can figure out the area. And so if you know anything about special right triangles, I bet you can figure out the h very quickly. Let's just say I don't know the special right triangle, and I'll use the Pythagorean theorem because we have a 90-degree angle. If this base down here is 7 and the top base is 5, that means I'm going to have 2 right here. So that little triangle area, if I redrew the triangle, we'd have 2 units right there. And 5 of it units would be to the right. Doesn't look like it's drawn to scale for these numbers given on the problem. And 4 would be here, and yeah, you'd have 60 degrees there. There's your right triangle. And so the h is what you're trying to figure out. And so it looks like Pythagorean theorem, we'd have 2 squared plus h squared equals 4 squared. And so 4 plus h squared equals 16. Subtract 4 on both sides. H squared would be 12, and then to cancel out the square, you have to square root both sides, leaving you with a height equaling about 3.46. Okay, so that's your height. Let's go ahead and plug it in our formula. So we have 3.46 for our height, times 7 plus 5, all over 2. So 3.46 times 12, all over 2. And that will give you an answer of 20.76. And we don't have any units given in this problem, so we'll just write units squared. Alright, so that concludes it. We have our examples here, and our definitions and little diagrams for our shapes.